All right, so on number 2, we've decided we're going to complete the square. So let's remember how we're going to do that. We are going to go say that I'm just going to look at the integrand 5 over x squared plus 6x plus 18 is equal to 5 over, so I want to do half of 6 is 3 and square it, and we get 9. So I'm going to have x squared plus 6x plus 9. And then what do I need to make up the 18? Plus my favorite number here, which is 9. All right, so then that equals 5 over x plus 3 squared plus 9. So that's the completing square method, completing the square method or process. So now I'm going to say that my integral of 5 over x squared plus 6x plus 18 dx is equal to, I'm going to go ahead and pull the 5 out right away and say that is the integral of 1 over x plus 3 squared plus 9. And then we're going to note here that a equals 3. And then we have this nifty integration formula. I put the integration formula right here on techniques 2, the one that you're going to do. Here's the technique. The integral of u squared plus a squared du is equal to 1 over a inverse tangent u over a. So the u could be any function of x. In this case, the u is x plus 3, right? So this is using u equals x plus 3, all right? But we don't have to like write out a substitution u and du because this integration formula already handles that for us. So we can just say that that equals, we'll keep our 5 on, and then we'll go, we have 1 over a, so that's 1/3, and that it is inverse tangent, and then it's u over a, so that means the x plus 3 over the a, which is 3. That's our u over a from that formula. And then I have plus c, and voila, number 2 is done. All right, so that brings us to number 3. Number 3, I have integral of 3x squared plus 3x over 4x cubed plus 6x squared dx. So I could think about the fact that I could factor that denominator. I could think about that, but I should not think about that first. That is not the first thing I should think about. The first thing I should think about is degree of p greater than degree of q? It's not. P is 2, q is 3. Do I have kq prime over q? In other words, could I use a substitution? U equals q of x. Could I do that? Well, let's check that. So if I did u equals 4x cubed plus 6x squared, then du equals 12x squared plus 12x dx. Yeah, I could. That's just that times 4. This is the numerator times 4. So you could say like this. You could say q prime is equal to 4p. Right. To put it in terms of the what it means to say. Oh, where is this? Sorry, where is this? What it means to say p is equal to kq prime. Right, the way I say it on the where's the flow chart? On here, p is equal to kq prime. All right. The numerator is equal to 1/4 q prime. So I could say it like this: p is equal to 1/4 q prime. Right? So then I could do that. I could divide both sides by 4 and say 1/4 du equals 3x squared plus 3x dx. Then I have a nice match up there. So then I can just finish this out using substitution. And probably if you're good at the substitution practice by now, which you probably are, you can right away say, okay, I'm said right here, like you need this part over here. Right? I said over here that u is 4x cubed plus 6x squared. So I can substitute that u. And then 3x squared plus 3x dx is what I got up here. That's du, and then the 1/4 goes outside. And I can just put equals because that line follows from that line, so that works pretty well. And then I can say this equals 1/4 ln absolute value u plus c, and then that equals 1/4 ln absolute value of 4x cubed plus 6x squared plus c. So that's number 3. All right, so that's looking for, so what happened on number 3 is, you're always watching for this. Is the numerator the derivative of the denominator or a constant multiple of the derivative of the denominator? All right. Next up, number 4.